Hi, I'm Herb Gross, and welcome to Lecture 4 of Gateways to Algebra, where today we're going to talk about subtracting sine numbers. And the first thing we're going to have to come to grips with is, again, a general concept where I guess it's an application of an ounce of prevention is worth a pound of cure. That sometimes by doing something that's intuitively easy, and it works in simple cases, we build ourselves into a trap that later on is going to cause us a problem. And unfortunately, it turns out that in dealing with sine numbers, subtraction is one of those topics. And let me see if I can show you why. See, in a subtraction problem, when I write down this expression over here, how do you usually see? The word takeaway doesn't appear here. All you see here is a minus sign. What this should be read as is what? 5 minus 3. Now, I don't know how you were taught, but when I went to school, we weren't taught to say 5 minus 3. We were taught to say 5 take away 3. In other words, rather than using minus, we use the word take away. So, for example, let's look at take away over here. If you say start with 5, take away 3, the answer would be 2. In other words, here's 5, take away 3, the answer is 2. I say no. What we should have learned to say is that 5 minus 3 means the number we must add to 3 to get 5 as a sum. Okay? In other words, let me see if I can write this a little bit better here. 5 minus 3 equals blank means blank plus 3 equals 5. I don't know if you were taught this way or not, but for example, when you did take 5 take away 3 and the answer was 2, when you did that problem more traditionally, how were you taught to check this problem? Didn't you add the bottom number to the middle number to see if you got the top number? In other words, notice that the check for 5 minus 3 equals 2 was that you added 2 to 3 to see if the answer was 5. So in reality, what we're going to do from now on is we're going to say 5 minus 3 equals blank means blank is the number you have to add to 3 to get 5. And if you want a simple way to visualize that, simply take the minus sign on put the equal sign where the minus sign was. Where the minus sign was, put a plus sign. And this reads now what? 5 equals 3 plus blank. In other words, the first number minus the second number means what number must you add to the second number to get the first number? And here's a good place to pause again. If you've been learning something for a number of years one way, now I come in and I tell you right away, here's the way I want you to do it from now on. It's going to take you longer to be comfortable doing that than it is for me to say it. So again, let me remind you, as I often will in this course, if you find your head spinning, figuratively so to speak, stop the tape, pause it, look at this last frame that we wrote on, and try to make it become natural to you. Now, before we go on that way, let me show you why, in the case of what we've been doing in the first and second grades, why it makes no difference whether you use the minus interpretation or the takeaway interpretation. See, let me show you how that works. I'm saying that what? 5 minus 3 means the number you must add on to 3 to get 5. Well, one way of doing that is what? Start with the 5 that you want to wind up with. Then subtract the 3 that you already have. See, take away the 3 that you already have, and what's left tells you what? What you must add on to 3 to get 5. You see, the average person, I hate to use the word average, but you know how I mean that. Most people will look at this, and if I say read this, without looking what came above, they'll say what? Oh, you had 5 tally marks and you took away 3. No, what I want you to say is the 3 tally marks that are crossed out plus the 2 that aren't crossed out add up to 5. And by the way, again, let me show you that this is not as unusual as you may have thought. Of course, now with the advent of calculators and computers, we don't make change that way anymore. But hypothetically, let's suppose you go into a store and you buy something for $2.34, and you pay for it with a $5 bill. Nowadays, they have what? A computer, type cash register, and the machine computes the change for you. And I don't mean this as a slur on anybody, but if you want to have fun today, just go into a supermarket, a super drugstore, and check out with 6 or 7 items, pay with a $20 bill when the computer is down. And watch people scramble to try to figure out how to figure out the cost of everything. But in the old days, they had a better way of doing this, and maybe you remember it. In the old days, before they had the computers, what they did was, when you came in and bought something for $2.34 and paid for it with a $5 bill, they didn't subtract $2.34 from $5. They didn't say, let's see, we can't take 4 from 0, so we have to borrow and go through all this stuff. What did they do? They said $2.34, then they put down a penny and said, and 1 cent makes $2.35, then a nickel makes $2.40, a dime makes $2.50, then they put down 2 quarters and say that makes $3, and 2 more dollars makes $5. You see, what they did was, they never gave you the $2.34 when they said that. They just said that, and then what did they do? They added on to the $2.34 the amount of money that it took to make up the $5. In other words, what they did was, is starting with $2.34, they figured out what to add on to this to wind up with $5, okay? And at this stage, you can say, look, I understand this, it's nice, it's cute, who cares? You're telling me that if I do it your way, I get the same answer as if I did it my way. I'm already comfortable with my way, why should I do it your way? Does it make sense to find the harder of 2 ways to get the same job done? And I'd have to agree with you. If ever you want a person to pick the harder of 2 different ways to get the same job done, you had better be able to show them why the harder method brings rewards and satisfaction that the easier method doesn't. Otherwise, it doesn't make any sense to do it the harder way. So let me show you now, with this as a lead-in, why it is so important to get rid of the takeaway syndrome if you're going to be dealing with subtraction of sine numbers. Hopefully, this will be a meaningful discussion, because to take that long of a lead-in to have something that's not very sensational wouldn't be very valuable. Here's a problem for you. 5 minus negative 3. By the way, we said that whenever there's no sign, it means positive. So 5 minus negative 3 means positive 5 minus negative 3. Now let's use the concept of takeaway over here. Read this as takeaway. You have 5 and you take away negative 3. Does something bother you already from that? Think about it. Look, suppose I have 5 pieces of candy on the table, and I say, take away whatever you want. What's the least you can take away? None. They say, I don't want any. What's the most you can take away? 5, that's all that's there. You say, couldn't I take away 6? How can you take away 6? Well, isn't 5 minus 6 equal to negative 1? Like if it's 5 degrees out and it drops by 6, isn't that 1 below 0? Hey, if you can take 6 pieces of candy from a dish that has 5, you can walk on water. The reason the dish would owe you 1 piece is you can only take away 5. Well, in particular, what's the least you could take away? None. How can you take away negative 3? How can you take away negative 3? 5 take away negative 3. I can take away none. I can take away 1. I can take away 2, 3, 4, 5. I can't take away negative 3. Now let's look at our other definition, though. What was the real definition? It says what? The first number minus the second number means what number must you add on to the second number to get the first number? In other words, what must you add on to negative 3 to wind up with positive 5? Okay? And all I want you to see over here again is let's go back to a profit and loss analogy again. You have a $3 loss, so the 3 goes in the loss column. And what do you want to wind up with? A $5 profit. By the way, notice the difference between this diagram and what we were doing in the previous lecture. In the previous lecture, we talked about what? A $3 loss followed by a $5 profit. The profit was written above the line. In this lecture, we're saying what? What must the transaction be over here in order to make this a $5 profit? Now again, you don't even have to look at what's above over here. How would you look at this? First of all, to wind up with a $5 profit, starting with a $3 loss, isn't it obvious that you would first want to make a $3, that you have to make a profit? Because a loss plus a loss would add up to a loss. So obviously the second deal has to be a profit. How big does that profit have to be? Well, the first thing is you have a $3 loss, so the first thing you would need is what? A $3 profit just to balance the $3 loss. That would give you what so far? Breaking even. $3 loss followed by a $3 profit would break you even. You want to wind up with a $5 profit. So far you have a $0 profit. Therefore you need $5 more. So altogether, what did you need? $3 and $5, and that would have been what? 8. And does that check, by the way? An $8 profit followed by a $3 loss. How do we say you add sine numbers? If they're in opposite columns, subtract the smaller transaction from the greater, 3 from 8 is 5, and put the answer in the column with the greater transaction, the 8. So the 8's in the profit transaction column, so the answer is what? Positive 5. And again, here's a good place to stop if you find that this looks strange to you. But let's summarize this. And how am I going to summarize it? I'm going to summarize it without using the profit and loss, because after all, we could have been talking about increasing and decreasing. For example, we could have said, how do you go from 3 degrees below 0 to 5 degrees above 0? What does 5 minus negative 3 mean now? It means what must you add on to negative 3 to get 5? And the way the game is played is you say, look, the negative 3 doesn't appear in the answer, so I want to get rid of the negative 3. What can I add on to negative 3 to neutralize it? Answer, positive 3. Why is that? Because positive 3 added to negative 3 gives me 0. And keep in mind, you see, I can add in any order I want, so these brackets and braces don't bother me. Negative 3 and positive 3 brings me back to 0. What must I add on to 0 to get 5? 0 is the additive identity. To get 5, I have to add 5 onto 0. So you see what's happened inside the braces now? I first had to have positive 3 to neutralize the negative 3, and then positive 5 to get me to the $5. I put a dollar sign in here. I meant the plus sign, positive sign. Positive 3 plus positive 5 is what? Positive 8. And how would you check this? A positive 8 and a negative 3 equals a positive 5. Now, again, what we often do for people is we give them shortcut ways to learn how to do a problem. See, look at the problem. Look at the answer. See, look what happened over here. The problem started with positive 5. Was positive 5 part of the answer? Yes. The problem also had a negative 3. When you went to the answer, was negative 3 still there? No, the 3 was there, but the negative had become positive. The problem starts with a minus sign. Does the answer have a minus sign? No, the answer has a plus sign. So in other words, if we want to teach a person a mechanical way of getting the answer through addition, we say what? To subtract, we add the opposite. In other words, leave the first number alone, change the minus to a plus. See, change the subtraction to addition. Then you do what? Change the sign of the second number, and when you change the sign of a number, it's called the opposite. You see, notice that a number can only have 2 signs, positive and negative. So one is the opposite of the other. You see, if it's not one sign, it's the opposite sign. Okay? Let's just practice with a couple of these to make sure that you understand this, just mechanically. Negative 10 minus negative 17. And again, notice the minus versus negative. The minus sign tells me I'm subtracting. The negative tells me that the numbers I'm dealing with are decreases. In other words, negative 10 minus negative 17. Okay? What's the mechanical way of doing this? Leave the first number alone, change the subtraction to addition, change the sign. In other words, replace the second number by its opposite, and then do the resulting addition problem. See, negative 10 minus negative 17 means the same thing as negative 10 plus positive 17. We already know how to add. You see what's happening here? Every subtraction problem can now be replaced by an addition problem simply by replacing what? Subtracting a number by adding its opposite. How do you add a negative 10 and a positive 17? opposite signs, subtract the smaller magnitude from the greater, 10 from 17 is 7, keep the sign of the number with the greater magnitude, the 17 is greater than the 10, it's positive, so the answer is positive 7, and as a check, positive 7 plus negative 17 is indeed negative 10. A $7 profit followed by a $17 loss gives you a $10 loss. By the way, unlike addition, where order doesn't make any difference, in subtraction it does. Let's look instead now at instead of negative 10 minus negative 17, let's switch the order and look at negative 17 minus negative 10. The rule stays the same. Leave the first number alone, change the negative to positive, replace the second number by its opposite, and do the resulting addition problem. We proceed the same as before. Numbers have the opposite signs, so we subtract the smaller magnitude from the greater. 10 from 17 is still 7, but now the greater magnitude, which is still 17, happens to be negative, so the answer now, instead of being positive 7, is negative 7. You see, when you change the order, you also change the sign of the answer. And by the way, to check this, let's see if this is true or not. A negative 7 added to a negative 10. See, same sign, add the magnitudes, gives you 17, and keep the common sign. $7 loss followed by a $10 loss is a $17 loss. And by the way, if you want to see what this means in terms of the number line, what this says is, okay, if you're starting, if you see the first number is where you're going to, and the second number is where you started from. To get to negative 10 from negative 17. See, to get to 10 to the left from 17 to the left, don't you have to go 7 units to the right? But to get to this number from this number, you still have to go 7 units, but in the negative direction. In fact, one of the first things that's happened by this definition of sine numbers is we now can do, look, let's suppose a person is 50 feet above sea level. Something else is 150 feet above sea level. He wants to go from 50 feet above sea level to 150 feet above sea level. You've never heard of sine numbers. How would you do this problem? Wouldn't you say something like, well, let's see. He's winding up at 150. He's starting from 50. So I'll subtract where he started from to where he's going, and the answer will tell me how far he's climbed. So 50 from 150 is 100, and therefore, let's call these units feet. To get from point A to point B, wouldn't you have to go 100 feet in the upward direction? We'll call upward positive here. Let's suppose instead of going from 50 feet to 150 feet, suppose the person started at 50 feet below sea level, negative 50. Well, what we did in the positive case is we said what? Take where you're going to and subtract where you started from. Person says, but when you subtract, doesn't that make things get smaller? See, the person says, shouldn't we add over here? Don't worry about it. The beauty of the rule for sine numbers takes care of that for us. Namely, where are we starting? At 150, which of course means, where are we finishing? At 150, which means positive 150. Where are we starting from? 50 feet below sea level. That's negative 50. What do? Subtract where you're going, where you're leaving from, to where you're going. This problem would say what? You take the 150 and subtract the negative 50. What's the rule for subtracting? Leave the first number alone, change the subtraction to addition, change the sign. In other words, replace the second number by its opposite. What's positive 150 and positive 50? Isn't that positive 200? And therefore, to go from 50 feet below sea level to 100 feet above sea level, all you have to do is what? Go up 200 feet. And the beauty of this system is I never have to draw this diagram. All I say is what? I'll take where I'm going, subtract where I started, and that sine number will always tell me how far I have to go and in what direction. But the most important thing is that once we invent sine numbers, we never again have to subtract. Rather than subtract, we can always add the opposite. And to give you a preview of where we're going to go after we do sine numbers, remember we said something like start with a number and subtract it from 15? Well, in the language of algebra, that would be written as 15 minus x. See, in other words, here's the number subtracted from 15. If you wrote x minus 15, that would mean start with the number and subtract 15. This is the one we could do before. This is the one we're trying to do now. Watch what's going to happen over here. What's eventually going to happen is, instead of saying start with x and subtract it from 15, we're going to be able to say what? Instead of subtracting x, we're going to be able to do what? Add the opposite of x, and that's going to be a very important tool. See, now what we're going to say is what? Start with x, change its sign, and add 15, and that will be the same thing as if we said what? Start with x and subtract it from 15. That's just an aside, and I don't want to linger on that, but let me also show you that you've done something similar to this already, but may not realize it. And that is, once we invent fractions, we never again have to divide. You see, the two nice operations of arithmetic are multiplication and addition. Why? Because when you multiply, you can multiply in any order you want. You can group any way you want. The same for addition. But subtraction and division don't behave that nicely. Order makes a difference. Grouping makes a difference. Therefore, to do mathematics systematically, if we can replace subtraction by addition, we're replacing a badly behaved operation by a good behaved operation. If we can replace division by multiplication, we're again doing the same thing. And let me point out to you a tremendous parallel between subtracting and dividing. How do you subtract? You add the opposite. How do you divide? You multiply by the reciprocal. See, the reciprocal is to multiplication what the opposite is to addition. See, 0 is to addition what 1 is to multiplication. What do you have to multiply 2/3 by to get 1? 3/2. You see, reciprocal? You replace the operation by the inverse operation and the number by its inverse operation. So, for example, let's look at this problem over here. What's 2/3 divided by 5/7? You were taught mechanically to leave the first number alone, change the division to a times, and invert the second number. But let me show you the logical way of doing this. 2/3 divided by 5/7 means what? The number you must multiply by 5/7 to get 2/3. What number times 5/7 gives me 2/3? Watch how neatly I can do this problem by logic. Okay? I want to wind up with 2/3. That means I want to get rid of the 5/7. What can I multiply 5/7 by to get rid of it? 7/5. The 5s will cancel, the 7s will cancel. That leaves this a 1 now, doesn't it? What do I have to multiply by 1 to get 2/3? Just 2/3 itself. Therefore, what's the answer going to be? 2 times 7 is 14. 3 times 5 is 15. The answer is going to be 14 over 15. Now, once I have the answer, I can say what? Let's compare the problem with the answer. The problem starts with 2/3. The answer starts with 2/3. The problem starts with division, or has division next. The answer has what? Multiplication. The problem has 5/7 for the second number. The answer has 7/5. So if I now want to multiply, all I have to say, if I now want to do this mechanically, all I have to say is what? Leave the first number alone, change the division to a times, and invert the second number. I may not remember what that means. I may get confused and memorize incorrectly and invert the wrong one. But if I understand the logic of what I'm doing, can you see how I've solved every division problem by converting it into a corresponding multiplication problem? And in fact, let me show you how this works in the real world. See, suppose I can buy $6 for 2 pounds. In other words, 2 pounds cost me $6. What's the rate? In other words, what's the dollars per pound? If it's $6 for 2 pounds, 6 divided by 2 is 3. That would be $3 per pound. What if it was $6 for a half a pound? According to per meaning divide, that's going to be 6 divided by a half. But let's see how we can figure this thing out logically. First of all, how many half a pounds are there in a whole pound? 2 half a pounds, right? Okay? So in other words, if I'm paying $6 for a half a pound, for a whole pound, I'm going to pay what? $6 2 times. And that's $12 a pound. See, when you say 6 divided by a half is 12, all that says is what? Compared to a half, 6 is 12 times as big. So 6 divided by a half equals 12. Isn't that true, by the way? At $6 per half pound, wouldn't that cost you $12 for a full pound? Now watch how the mechanical rule works. Leave the first number alone, change the division to a times, and invert the second number. The inversion of 1/2 is 2 over 1, which is the same as 2, and we therefore get the right answer. And by the way, in closing today's lesson, keep in mind why it's important not to forget the order in either a division problem or a multiplication problem. Notice that 5 divided by 2 and 2 divided by 5 are two entirely different numbers. For example, when $5 is shared equally by 2 people, each person gets $2.50. When $2 are shared equally by 5 people, each person only gets 40 cents. In a similar way, if we look at 7 minus 3, the answer is 4. But if we look at 3 minus 7, and what does 3 minus 7 mean? Remember, if there's no sign, it means positive. And to subtract, you add the opposite. See, 7 minus 3 is 4, but 3 minus 7 is negative 4. And at any rate, this completes our treatment of adding and subtracting sign numbers. And what's left now? Multiplying and dividing. And in a sense, can you see that only multiplication is left? Because once we multiply, isn't dividing just invert and multiply? So in our next lecture, we will talk about how you multiply sign numbers. And until that time, again, work hard, enjoy yourself, stay young.